Many large machines, such as excavator travel drives, agricultural equipment, and forestry machinery, almost always use the same hydraulic configuration. A variable piston pump combined with a closed-loop hydraulic system. But this raises an interesting question. Why do closed hydraulic systems almost always use variable pumps? Can't a fixed displacement pump do the job? Let's break this down in about 1 minute. First, let's understand what a closed-loop hydraulic system actually is. In a closed system, hydraulic oil mainly circulates between the pump and the motor. Unlike an open system, the oil is not constantly drawn from the tank and returned to it. Simply put, the oil circulates within the system instead of continuously flowing in and out of the reservoir. But this creates an important requirement. The system's speed and direction must be controlled directly by the pump. And this is exactly where variable pumps become essential. A variable piston pump can change its displacement by adjusting the swash plate angle. When displacement increases, flow increases, and the motor rotates faster. When displacement decreases, flow decreases, and the motor slows down. It can even make the displacement negative, which reverses the direction of oil flow. In other words, by adjusting the pump itself, you can control both the speed and direction of the machine. Now let's look at what happens if a fixed displacement pump is used in a closed system. A fixed pump has a constant displacement. If you want to control speed, you would have to rely on throttle valves, bypass relief flow, or more complex valve control systems. The result is lower efficiency, more heat generation, and less stable control. Variable pumps provide three major advantages in closed hydraulic systems. First, infinitely variable speed control. Flow can be adjusted directly without throttling. Second, simple directional control. Changing the swash plate direction immediately reverses the motor rotation. Third, higher efficiency, because energy is not lost through throttling. That's why in many machine travel drives you often see this configuration. A variable piston pump combined with a piston motor in a closed loop. So in simple terms, a closed hydraulic system requires speed control, directional control, and high efficiency, and a variable piston pump can deliver all three. That's why variable pumps almost always appear in closed-loop hydraulic systems.